today we are going to continue talking about rates of reactions like we have been working on in our labs the past few days. Remember, we worked with the Alka-Seltzer and water reaction, and we changed different variables to see how that would affect reaction rate. Well, today, instead of just using a stopwatch to see how long a reaction takes to complete, we are going to use this temperature probe and record the temperature change as a reaction occurs. Now, does anyone have any idea if a chemical reaction causes the temperature of a solution to increase or decrease? Dave?
Most chemical reactions are exothermic.
Okay, what does exothermic mean?
That means they give off heat to the surroundings.
So temperature would...
Increase.
Okay, good. Temperature would increase in an exothermic reaction. Does everyone remember learning about endothermic and exothermic reactions? Debbie?
Those temperatures would decrease and they happen inside of the reaction.
In what type of reaction?
Endothermic.
Endothermic, good. So remember, endothermic reactions, heat is entering the system, enter, the EN part. And in those reactions, heat is given off or consumed.
Consumed.
Okay. And in exothermic reactions, heat exits the system and temperature increases or decreases.
It increases.
Dave, increases? Okay. So does anyone have any idea of what this Alka-Seltzer and water reaction is? Endothermic or exothermic? Debbie?
Exothermic?
Exothermic? Okay. Well, we're going to find out. Alright, so first for our lab setup, we have two options of cups. We can use the glass cup or the styrofoam. What do you think we should use for this experiment? Debbie?
I think definitely the styrofoam,
Why do you think styrofoam?
because we're going to be measuring the temperature, and if it were in the glass, the styrofoam will keep the temperature stabler than the glass. The glass.
Okay, so what kind of material is styrofoam? Dave?
It's an insulator.
Insulator, good. It's a heat insulator. Think of your hot cup of coffee. Well, you have it in styrofoam and you can't feel the heat because the styrofoam is a good heat insulator. It keeps the heat in the system, and we want the heat to remain in the system, so when we're measuring the temperature, we know that all the heat that we're measuring is staying in the system. Alright, so we're not going to use the glass. Alright, this is just our traditional trial one like you guys did yesterday in lab. It's 60 milliliters of room temperature water. And we're going to put the temperature probe in and see what the temperature is. What's the temperature of the room temperature water? Debbie?
22.3 degrees centigrade.
Okay, great. All right, and so I'm going to start collecting data and drop the tablet in. All right, let's change the scale so we can see the data. All right, what are we starting to notice? Debbie?
The temperature is dropping.
Temperature is dropping, so what kind of chemical reaction must this be? Dave?
Exothermic.
Exothermic.
Oh, endothermic.
Endothermic?
Endothermic.
Debbie, what do you think?
Endothermic.
Endothermic, all right. So temperature is dropping, which means the temperature is entering the system and being used in the reaction. So it's going to, since it's entering, it's going to be endothermic. All right, good. I'm just going to continue slowly stirring it to make sure the heat is being transferred throughout the entire solution. And how will we know when the reaction is done? Debbie, I saw your hand first.
I think that it might level off. The temperature will just kind of level off and stabilize.
Okay, so temperature is stabilized because...
There won't be any more reaction occurring.
All right, so it's not going to be consuming any more heat. All right, and starting to stabilize. All right, looks pretty stable now. So we're going to stop collecting data, and our reaction time is going to be when it started to level off. Looks like it was at 68 seconds. So what did you guys get yesterday in your trials? Dave?
70.
70 seconds. All right, so what do you think? Is that pretty similar?
Yes.
All right. So we've now seen that using the temperature probe gives an accurate way of seeing how long a reaction takes to occur. All right, so now I have some hot water. Whoa. Now, Do you think using a hotter water will cause reaction time to increase or decrease? Dave?
Increase.
Increase? All right, so you think it's going to take longer for the reaction to occur?
No, shorter. Reaction time
Shorter?
increases, it should consume all the energy sooner.
So fewer seconds would be decreasing.
Yes.
Okay, all right, good. And so it looks like our temperature has leveled off. And what's the temperature reading, Debbie?
56.3 centigrade.
All right, great. So I'm going to drop in the tablet after I start collecting data. All right, and does it look like heat is, do you think it's an endothermic or exothermic reaction now? Dave?
Endothermic.
All right, so it hasn't changed even though the temperature's changed?
No, temperature is still dropping, so it's still consuming energy.
All right, good. So we can now tell that the temperature of the reaction doesn't change whether or not it's endothermic or exothermic. All right, and when will we know the reaction's done occurring now? Debbie?
Well, it should sort of stabilize. The temperature will stabilize and not continue to drop.
Not continue to drop. All right, looks like it's still going.
But not as fast.
Not as fast. Dave, do you have any ideas?
Yes, I was wondering, well, since the water was hotter, won't it naturally cool? So do we have to consider that in the reaction?
Good, that's a very good observation. It looks like we now have a linear decrease in temperature, which is probably just from the water cooling down. So I'm going to stop collecting data. And if we look at this data, how will we know when the reaction stopped? Since we know that there's a linear decrease in temperature.
When the linear decrease started.
Okay, good. So if we see this linear decrease just from the cooling of the water, it looks like right here around 38 seconds is where heat stopped being consumed by the reaction. What reaction time did you guys get when you used the about 60-degree water yesterday in lab, Debbie?
About 36.
36. All right, so it's really close, right?
Yes.
Okay, good. So what have we learned today?
So we learned that the increase in temperature of the solution that the Alka-Seltzer is being dissolved in increases reaction and decreases the time it takes it to consume.
Okay, and what did we learn about this being endothermic or exothermic? Dave,
We
again?
learned that it's an endothermic reaction no matter whether it's at room temperature or elevated temperature of the water.
Okay, good. So now I'm going to have you guys write down your observations, and in your post labs, you're going to compare this data to what you saw in your experiments from yesterday. Any questions? All right, thank you.